This problem is related to the concept of Ampere's circuit law, and problem says an infinitely long wire located on the z axis carries a current I along the positive z direction and produces the magnetic field B. So, this is my x direction and this is my axis, and z axis is coming out of this screen. So, z axis is denoted by a dot. So, we have the wire that carries current I along the z direction. So, this means the wire is somewhere here. The magnitude of line integral B dot dl along the straight line from point minus root 3a a0 to coordinate a0 is given by. So, here I have a point and the coordinate of this point is this one, and this point is this one, because x and y both are positive. So, it should lie in this quadrant. So, this point is somewhere here. So, we have to find this integral B dot dl along this path, that is from I to f, and constant mu naught is given. So, we have been given 4 options and then we have to find which option is the correct. So, let us try to solve this problem. Now, first I will use geometry to find this angle and this angle. This has a coordinate of minus root 3a a0 and this is a coordinate of a0. This means x distance is a and the y distance is also a. For this point, x distance is root 3a, basically negative direction of x axis, and the y, this coordinate or this distance is a. And in both cases, z coordinate is 0. This means this whole figure lies in this plane. Now, let us say if I use, let us call this angle as theta 1. So, we can write tan theta 1. So, tan theta 1 will be this distance divided by this distance, and this distance is a and this distance is root 3a. So, this means this is 1 by root 3. So, we know when theta is equals to 30 degree, tan theta is equals to 1 by root 3. So, this means in this case theta 1 is equals to 30 degree, which is basically equals to pi by 6. Now, let us consider this angle. Once again I can write tan theta, let us call this angle as theta 2. So, tan theta 2 will be this distance divided by this distance, that is a, that is this distance is a and this distance is also a. So, a by a, this is equals to 1. This means theta 2 is equals to 45 degree, that is pi by 4. So, now I know this angle and this angle. So, we can calculate this angle, basically pi minus this angle and this angle. So, the angle IOF will be pi minus pi by 6 minus pi by 4, and this if you calculate, this is 7 pi by 12. Now, what is Ampere's circuital law? This law says B dot dl in a closed path is equals to mu naught times I. So, this is the law, that is B dot dl is equals to mu naught times I. Now, if you consider this circle, integral B dot dl in this closed path will be equal to mu naught I. Now, this will be equally divided for this angle. So, this contribution mu naught I is coming from this part of angle and also this part of angle. So, basically this whole contribution mu naught I is due to the 2 pi angle. So, we can calculate what is the contribution due to this part of the loop. So, that will be mu naught I divided by 2 pi and multiplied by this angle. So, we can write contribution due to this one is equals to mu naught I divided by 2 pi times this angle, 7 pi by 12. So, this will be mu naught I divided by 24 and this multiplied by 7. So, 7 by 24 mu naught I. So, now I know the contribution or the value of B dot dl for this path. Now, if you consider this loop from here to here and then from here to here, this loop does not contain any current. This means magnetic field B, mu naught I will be 0. This means B dot dl due to this part will be equal to B dot dl due to this part. Only thing, there will be a negative sign, but in the question we have to only give the magnitude. So, B dot dl due to this portion is same as B dot dl due to this portion, but I know B dot dl due to this portion, that is this value. This means B dot dl due to this portion is also same. So, that is basically 7 mu naught I by 24 and this was option A. So, option A is the correct option. So, I hope you like this video, and if you like my videos, please share with your friends, like on my channel and subscribe to my channel. I will see you in the next video. Thank you.